Humans both reflect and emit. We reflect visible light, and so ordinarily every day we see each other by the light that's reflected off our clothes, our bodies, and so on. But if you could see with infrared light, let's switch to an infrared camera, and you can see that, as promised, I'm emitting lots and lots of infrared light. Because people are much cooler than stars, most of the emission that comes out from us is infrared light. Now, your eyes can't see infrared light. You can sometimes sense it as heat. Hotter is brighter in the infrared, and cooler is darker with this camera. So you can see on my face, on my hands, you can see different amounts of heat and cool, different amounts of infrared emission. We can have some fun with this. If I take a bowl of ice, right, it's just plain old ice, put my hands in it, let the ice water come down. Looks probably a little like Dracula. I can take a piece of ice. I've always wanted a mustache. So heat and cold, high or low infrared emission. If you could see the infrared, this is what you would see, but we have cameras. We use them all the time in astronomy, and we use them to study the stars. Don't be fooled by reflected light or reflected colors. When we talk about the colors of stars in the sun telling us what their temperature is, we're talking about the light that they emit. If you talk about people, you don't see the light we emit unless you see the infrared. You see light that's reflected off our clothes and off of us. And that depends not only on what we're wearing, what our properties are, but it depends a lot on the light that's reflecting off us. I can show that to you in a very fun and quite astonishing way by bringing you into the yellow light room. In the yellow light room, we can turn on a light source that is very, very bright, but it is purely the color yellow. It actually is an emission spectrum of sodium, and it's a parking lot light. Low-pressure sodium parking lot lights put out pure yellow light. If you want to think about it that way, there will only be yellow photons in this room. What do you think things will look like when we're in a brightly lit room with pure yellow light? What will my shirt look like? What will colors look like? Let's try it and find out. We're in the yellow light room, and my hand is in a bowl of crayons. Can you tell what color these crayons are? Take a very good look. And now we'll turn on the white light in the room. Whoa! They really are different colored crayons, but you can only see that when there's white light, which, as you know, is a mix of all the different colors to reflect off the crayons and reflect red, or reflect blue, or reflect green, or reflect other colors. Now my hand's in a bowl of gravel. Take a good look. Can you tell the colors of the gravel? Do you see various shades of gray? Do you see various shades of yellow? What if we turn on the white light? Whoa! Again. So as long as the light shining in here is only pure yellow, there's no red photons and blue photons, and you just can't see color. How about my shirt? Do you remember what it looked like? Here in the yellow light room, it's lost all sense of color. We can fix that by turning the white light back on. When astronomers actually measure the colors of stars or the sun, they do it precisely by using colored filters. A precise color measurement will tell you the precise temperature of a star. So how do they do that? Let's be sure we know how a filter works. What would happen to the spectrum that I make with a prism or a diffraction grating if I put a red filter into the beam? That's right. With a red filter, red gets through and the other colors disappear. What temperature object looks yellowish white? In other words, it has all the colors of the spectrum with a little bit more of the yellow and the orange and the green and overall it looks yellowish white to your eyes.